Um, enzymes today.
Enzymes, okay. Okay. What are enzymes? Any idea?
They are biological catalysts.
Okay, they
Speed
are
up a reaction.
very good. They are biological catalyst. And catalyst means they are speeding up the
Speeding up reaction.
anything else. Enzymes.
They're used to break down or as in like make
Break down.
substrates.
Do they break down?
In a reaction, it's either breaking down or joining.
Okay, so enzymes basically help down in breakdown. Okay, enzymes they help in the breakdown. Okay.
Okay.
Okay, so we'll start. Okay. Now enzymes in general they are the proteins. What are proteins?
Proteins are polymers of amino acids.
Proteins are
A polymer made of amino acids.
polymer made up of amino acids, right? Last class actually when we were discussing biomolecules we did that. Yes.
Yes, we did.
Proteins. Now these are enzymes. Enzymes are proteins and they function as the biological catalyst. Okay, they act as a biological catalyst. Like biologically they are helping up to speed up the reaction, and they are the that speed up a chemical reaction without being changed, right? Catalyst in generally speed up the reaction also, they do not change anything, right?
Right.
Now these enzymes they have a lock and key hypothesis. So first we'll see about that. Okay. Now enzymes, I told you they are proteins. They are proteins. Proteins, they are the complex structure of amino acids. So when they are folded together, they form into these 3D shapes. Okay. So enzyme into complex 3D shapes. Okay, and because of this 3D shapes, what happens is they allow small molecules to fit into them. Okay, because of this 3D shapes, because it is a huge one, right? Proteins and all, that is the reason. And when these places where these molecules are fit is called as the active site. 3D shapes allow smaller molecules to fit, and these molecules fit into these places, and they are called as the active site. Okay?
Okay.
Now, basically, what is this? I'll tell you. Now, I have a structure like this, okay? And what I'm going to do is I'm going to remove this part. Now, this is my enzyme, okay?
Okay.
This is my enzyme, and this part is my active site. The part which is here, this is my active site. Okay? Now tell me which among this, 1, 2 or 3 can fit over here?
Could 1 or 2 fit?
1 or
2.
1 or 2. Okay. 1 or 2 might fit. But exactly if we can see, it is only this first one may fit it over here. Right? Second one,
Right.
if I would have made it something like some other shape, it would be not possible, right?
Right.
So what it is exactly is, the enzyme and the shape of the active site should match the shape of the substrate. This is my enzyme. This part, this border is my active site. This is my substrate. Okay. So it's always that the shape of the active site matches to the shape of the substrate. Only this is possible. This makes the enzyme highly specific. Specific means only that shape can be fit into it. Can I go and match up the third one over here?
No, because it's not complementary.
Yes, it is a bit complement, right? So it is not going to get it because it is highly specific. Specific in the sense only specific substrates can come and attach to itself. And each type of enzyme can usually catalyze only one type of reaction. Only few of them may catalyze more, but most of them it is only one type of reaction. Okay? Now, take a similar example. So you understood this portion of lock and key hypothesis. What is lock and key?
Yeah, I understood that part.
Okay. The one where the substrate comes and attaches itself. Okay. Now we'll take another example of how it is happening. I'll take a small. Now this is my enzyme and I have a substrate this way. Now will this go and fit over here?
Yes.
Okay, yes, it is going to fit over here. Okay, so it is going, first of all, this is my enzyme, this is my substrate, and it is going to come and attach to the active site.
Active site.
Once it comes and attaches to its active site, what happens? This enzyme, it catalyzes the breakdown of the substrate. That means this substrate, right? It is a joint one. But when it comes and it is attached to it, what happens? The catalyst breaks off. That means it will be in this shape basically. So I'm not drawing into detailed one, but it will be this way, right? It is now attached, okay? It is coming, the substrate is coming and attaching itself to the enzyme. It is getting attached to the enzyme. Later on, what did I say was there is a breakdown of the substrate. So how is this breakdown possible? So this will now look like this active site is now again empty, and this empty active site can be replaced by any other substrate. Now this substrate which was joined together are now free. Okay, so what has happened here? There is a breakdown of the substrates.
Yes.
Okay,
Okay.
you understood this part? The whole concept
Yeah.
of lock and key hypothesis? Okay. First we saw was the active site, how these enzymes are specific. They come and they get attached to the enzyme, the substrates, okay. Then we saw how these substrates are getting breakdown, okay. Normally they come and attach to the active site, but once they come and attach to the active site, catalyzed over here and then they are broken down. Clear? Do you want me to write the entire process for you or have you understood this part?
Yeah, I've understood it.
Do you want me to write? If you want me to write, I'll write it for you. No problem.
Do you write it, please?
Oh, fine. So till here it is clear, right? The active site part.
Yeah, it's clear up to there.
I'll write it down then. This is the lock and key hypothesis, and this is the steps which are involved in a substrate breakdown.
Okay.
Tell me once you're done, then I'll start talking about another topic.
Okay, thank you. I'm done, thank you.
You're done?
Yep.
Next, we'll see what are denaturing enzymes.
Okay.
Now, enzymes, they work under specific temperature. Okay? Specific
Sorry,
temperature.
the screen is frozen again.
Okay, just
I'm sorry.
yeah, refresh it.
You are currently the only person in this conference.
No fan of radio? Ella fan, light, ella light.
You are now muted.
Please.
You are
Okay,
now
so I can
unmuted.
begin now. Thank you.
As I was telling you, enzymes, they work under specific temperature, specific pressure, and under specific conditions. Okay. Now, what happens if these enzymes, they are exposed to extreme level of pH? So there are certain conditions. Okay, what are those? pH level, temperature. Okay, what happens is the shape of the active site may change. We'll refer here. The shape of the active site may change. This shape, now if suppose there is only one substrate, now this is the enzyme, the active shape is in this way, okay, and there is only one substrate which can come and fit over here, but because of the exposure to pH, too much of pH and temperature, what happens, this active site, it is changing its shape like this. Okay, now will this come and get attached to it?
No.
No, that is not possible, right? Now, if this happens, what happens is this substrate will no longer come and fit into the enzyme. That means this key, this is the lock, this is the key, will no longer fit back. What we say is that the enzyme has now denatured. You understood how denaturing enzymes happen?
Yes, I understand that part.
This one. Okay, so because there is if the enzymes are exposed to extreme level of pH, temperature, what happens is the shape of their active site is changed. Okay, and if it is changed, substrate will no longer fit into the enzymes. That means the key will no longer fit the lock. Finally, what happens? Enzymes are denatured. Denatured means their nature is changed. Okay?
Okay.
The nature of the enzymes are changed. done, then tell me.
I've written that down.
You're done?
Yep.
Now we just saw here that pH, temperature, actually we should add concentration also, okay? Whenever these are getting affected, we have this denaturing of enzymes. Now we will see one by one of how they are affecting the enzyme, okay? So the
Okay.
enzyme catalyst reaction is calculated by measuring the rate at which a substrate is used up. Have you done rates of reaction earlier in chemistry?
Yes.
Okay.
Yeah.
Very much similar to that or over here, okay? So the rate of enzyme catalyst reaction is calculated by measuring the rate at which a substrate is used up, or by the rate at which a product is formed, okay? And generally we have a equation for that, that is rate of reaction is equal to the amount of substrate used or amount of product formed, the whole divided by the time taken. Okay, this is a rate of reaction formula. Okay, now we are going
Okay.
one by one of how they are affecting the enzyme. First we'll see is that of temperature. Temperature plays a major role in enzymes, okay? Now, there are many chemical reactions happening. These chemical reactions may happen in various environments, right? It may be in a very warm environment or in a very cold environment. That means it is depending upon the temperature. Now, what happens when we increase this temperature? When we increase this temperature, the rate of reaction will also increase, right? So, rate of reaction increases when temperature increases. Okay? But
Okay.
at a high temperature, what is happening? The rate decreases. Again, why? Because the enzyme becomes denatured, right? Now just
Right.
imagine there is an enzyme this way, okay, and there is a substrate. Rate of reaction is high when the temperature is increased. So when I am giving it an environment where it is good and it is increasing, the substrate comes and gets attached to it. But what if it is, I'm going on increasing, going on increasing, going on increasing? This active site will get denatured. Okay, this is what is here. At very high temperature enzyme becomes denatured. Okay, and always whenever we are talking about rate of reaction, all the rate of reaction are followed by a graph. Okay, so I'll draw the here. Okay, so it is starting from here, it is going, my rate of reaction is increasing as the temperature increases, but at a point what happens, it is falling down. Okay, and this point, the peak point, is known as optimum temperature. Okay, so you understood this one?
Yeah.
Now, as the temperature is increasing, the rate of reaction is also increasing. At optimum, where the enzyme's optimum temperature is at peak point, it is continued increasing in temperature. The temperature is increasing. But at a sharp deviation, you see there is a deep down, right? That means the rate of reaction is just falling down because now the enzyme has denatured.
Okay.
So that was a temperature. Factor C is that of a pH value. Okay. Now pH. What does pH tell about? What does pH tell about?
pH tells us about the acidity or if a solution's alkali.
Yeah. It tells about the substance being acidic or alkaline. Okay, the scale of level. Now, even if we change the pH of any kind of enzyme, it is going to alter the shape of the active site. Okay, what is a normal pH or a neutral pH value?
It's 7.
7. So most of the pH, they work very good when they are at 7 or even 7.5 taken into consideration. Okay. So when that is under pH 7, normal work. Okay. But there are some times where the stomach enzymes, the enzymes which are present in the stomach, they fall for pH 2. 2 means it becomes too acidic in nature. So what happens when it has become acidic in nature? As the pH is increasing, the rate of reaction is also increasing, but again at a point it falls down back, making the enzyme denatured. Okay?
Okay.
I'll mention that first. I'll just draw the graph over here. It's very much similar. My y-axis will have rate of enzyme activity, same as here. Here will be my pH level. pH, I start from 2, 4, 6, 8, 10, 12, 14. Optimum pH. Okay, you understood the pH factor also?
Yes, I understood that. I finished writing it down as well.
You have finished. Okay, moving on. We saw two factors, that is temperature and pH. Third factor which we are going to see is the substrate concentration. Okay. Again,
Okay.
work best if there is a plenty of substrate, right? If there is an enzyme and it has only one substrate, this substrate will come, bind it over the active site and it will leave, right? But if there are many substrates, okay, they will come, they get attached, right? So enzymes, they work best when they have many options. So what is happening here is, as the concentration of the substrate increases, am I going too fast for you?
No, it's okay.
Fine. So as the concentration of substrate is increasing, the rate of reaction is also increasing. Okay, the rate of enzyme active is also increasing. But here what happens is, it's not like the previous one which we saw in temperature and pH. What happens when we increase the temperature or increase in pH? What do we observe?
After you hit the optimum,
Yes.
it decreases, whereas in concentration, it'll just plateau off.
Yes. Now what happens when we increase the concentration? The rate of enzyme activity is not increasing. Okay, that means it becomes saturated. Enzymes, they become saturated. That means no more substrates can fit into them at one time. Even if they have empty space like this, they won't come and fit into them. Okay, so this is because of the saturation point. Now as the substrate concentration increases, the rate of enzymes also is increasing. The optimum rate now here, so for that optimum rate we need to draw a graph. So my graph will be this way now. Okay, you see how the graph is going? It is increasing, but after sometimes it has become saturated. Okay, now rate here is where the enzyme's optimum substrate concentration is there, and this continuous increase in substrate concentration results in that there is a good activity of enzymes, right? After that it is becoming saturated. So we do not have a particular optimum value in substrate concentration. Okay,
Okay.
you understood this part?
Yes, I've understood it.
Okay, fine. So this was the three factors involved with the enzymes. Okay, first one we saw was the temperature, second one we saw was the pH, and now is the substrate concentration. Okay, now we'll see how enzymes and food, they are related to each other. Okay, I have done biomolecules with you, right?
Yes.
What are the basic biomolecules we studied?
We did monomers, polymers, carbohydrates, lipids, and we
Those
just
polymers, they, okay, that means they come under, so we saw carbohydrates, proteins,
lipids.
lipids, right? Now these are the that are needed by the body, right? Basic
Right.
needed by the body for what? For growth, for repair, and for proper metabolism. Okay, they are required for growth, repair, and proper metabolism, and they all are found in our food, right? Basic food, what we consume, we have carbohydrates, proteins, and lipids in them. Now these molecules, they are very large enough. Why large enough? To pass through our digestive system, that is from the intestine. Okay, they're very
Okay.
complex molecules. The name itself, they are very complex molecules. So from intestine to the blood, it is difficult for them to pass. So what do they do is, I'll write it. They are large molecules. To blood. So what happens when they are difficult to pass from the intestine to blood is, there are certain digestive enzymes. Okay, there are certain digestive enzymes which break them into smaller molecules. Okay, so digestive enzymes, what do? Is they break these larger molecules into the smaller molecules. Because the work of the enzyme is to break down the substrate, right?
Right.
So they are breaking down into smaller molecules. Now once they are broken down into the smaller molecules, what happens? They are now transferred from the intestine to the blood. Okay, and once these enzymes are there, once in the body, that means these smaller molecules, once they come into the body, different enzymes will use them as a raw material to synthesize larger molecules. So it becomes like a circle, right? The enzyme circle. Smaller molecules, okay, then enzymes use this molecules as raw materials Okay.
Okay.
So this will become like a cycle. Again, they will synthesize the larger molecules. They will break down the larger molecules into smaller molecules, and they use up as a new raw material. Clear how enzymes and foods are related with this biomolecules?
Yes, that's clear.
And have you written it down?
Yep, I've written it down. Thank you.
So we'll see one biomolecule now. Okay. First biomolecule
Okay.
which we're going to see is about the carbohydrates. Now, carbohydrates are the most complex biomolecule, right?
Right.
Carbohydrates, they include the glycogen, then we have the starch. Can you name me some more carbohydrates, please?
Cellulose.
Cellulose, we have glucose, right? So
Right.
many are there, right? We can just pen it down. So glycogen, starch, cellulose, glucose, sucrose, these are the examples of carbohydrates. And why do we need carbohydrates in our body?
Like cellulose is used for strength,
They are the build.
and
They give us good energy, right? Basically energy, as you say. Okay. Now, the basic building block of a carbohydrate is the monosaccharide. I think I told you what are monosaccharides.
yeah, monosaccharides are it's the glucose structure.
The simplest form of carbohydrates. Okay, these are the monosaccharides. That means it is a simple sugar. We can say they are the simple sugars. So these monosaccharides, what do they have is they include the glucose and
Fructose.
okay. Now what happens is the enzymes, they join these monosaccharides together to form a disaccharide. Okay. So what is happening? Enzymes, they join in two monosaccharides, and now what we have is a disaccharide, right? Also, when many monosaccharides or many disaccharides are joined together, we have polysaccharide.
A polysaccharide.
So the main job of the enzyme over here is they are just joining all these monosaccharides together, monosaccharides as well as disaccharides. Okay, now they have formed a, because this was a simple form monosaccharide, am I right? It was a simple
Right.
structure, but now they have joined and joined and joined, and they have made a big complex structure, the polysaccharide. Now we need to break them down. So what are we going to use is, we are going to use this enzyme called as carbohydrates. Okay, carbohydrates is an enzyme which is going to break down disaccharide as well as the polysaccharides. You understood? Carbohydrates,
Yes, I understood.
these, it is going to break down the disaccharides and the polysaccharides back into monosaccharide. Okay. So now two or more, they are now again breaking down into single simple sugar. Okay, and carbohydrates enzymes are produced in the mouth. What are they termed as?
Sorry, what was the question again?
I said carbohydrates enzyme, this enzyme, it is produced in the mouth, what are they known?
In, I'm not sure.
When they are produced in the mouth, they are called as the saliva.
Oh, okay.
Okay, it's the saliva. Okay, so saliva has carbohydrates enzyme. We also see traces of carbohydrates in.
You are currently the only person in this conference.
Hello?
Oh, sorry. It just stopped for a second.
Yeah, okay. So as I was telling you, some traces of carbohydrates are also produced or are seen in pancreas, also there in small intestine. Okay,
Okay.
so you understood this part?
Yes.
So carbohydrates, when they are produced in the mouth, they are saliva. Traces are also found in pancreas and intestine. So what happens? Monosaccharides, they are joined together with the help of enzymes. They form disaccharides or polysaccharides. But carbohydrates comes, they break down disaccharides and polysaccharides back to monosaccharides. Okay, so that is
Okay.
about carbohydrates. Next, we'll see about proteins. Okay, again, proteins are large molecules made up of amino acids, right?
Right.
So these amino acids, they are joined together, they form this huge large chain, and now they are called as proteins. And these proteins, they include enzymes, because in the starting of the chapter, what did we see? Proteins are nothing but, enzymes are nothing but proteins. Enzymes are proteins. So now we see these proteins, what do they make up? Enzymes. They also form hemoglobin. They form collagen and also keratin. Okay, few examples of proteins. And each protein has hundreds and thousands of amino acids which are joined together, right?
Right.
Similar way as carbohydrates. Now they also have their own specific individual property. Okay, there are many proteins, like these are some of the enzymes, and each of these protein have their own individual properties. Fine, they have their own individual properties. Now when we're talking about proteins, when we had carbohydrates enzyme for carbohydrates, for proteins it is the protease enzyme. Okay, now this protease enzyme is responsible for breaking down the proteins. Understood this part? So I think
Yes, I've understood that.
in this color. Okay. So we have this protease enzyme that is breaking down proteins into amino acids. And again, different amino acids, they join together to form a new protein again. Okay. So because we are needing,
Okay.
why do we need protein? Protein is required for the growth
Growth, repair,
and repair.
metabolism.
Yes. And that is why it is always coming back to its original shape. Okay?
Okay.
Okay, then these protease enzyme, they are, sorry, these protease enzymes, they are produced in uh, again stomach, pancreas and small intestine. Okay, so proteins, they are found in the proteases they are found in the pancreas, stomach and small intestine.
I've written that down.
Yeah, finish writing it down. So just go through the things which we have done. Today we have not yet completed enzymes part, okay?
Okay.
There are still many things to be done, but since it's almost time, just go through whatever we have done today and tell me if you have any doubts regarding these.
I don't have any doubts at the moment. So.
Not much. So pretty much clear about what we have done till today.
Yes, I'm pretty much clear about it.
Fine. So shall we end up a class over here? I have another.
Yes.
Okay.
Thank you very much.
Okay then. Thank you.